Hello everyone, welcome to physics class standard 8 chapter 5 which deals with light energy. In today's video lecture we discuss about curved mirror. You already know about mirror. Any kind of reflecting surface is known as mirror. When the reflecting surface is plane or flat, it is called a plane mirror, and when the reflecting surface of the mirror is curved, at that time the mirror is said to be a curved mirror. There are two types of curved mirror. One is concave mirror and another one is convex mirror. Both concave and convex mirror are part of a sphere. You look at the figure. This is a hollow sphere and the two curved mirrors. One is convex mirror and concave mirror. These two mirrors are part of a sphere. So now what is concave mirror? A spherical mirror in which the outer surface is polished and the reflection takes place from the inner hollow surface is called a concave mirror. You see this figure. In this figure, AB is the polished surface. The outer surface is polished and reflection takes place from the inner side, inner hollow surface. So such types of mirror are called concave mirror. Now applications of concave mirror. Concave mirrors are used as a reflector in the headlights of cars, searchlight, etc. They are used by dentists to focus light on the tooth to be examined. They are used as shaving and makeup mirrors. They are used in solar heaters to collect radiations. Now we discuss about convex mirror. A spherical mirror. Convex mirror is a spherical mirror in which the inner hollow surface is polished and the reflection of light takes place from the outer surface. It's called a convex mirror. You look at the picture here. In case of convex mirror, the inner surface is polished and reflection takes place from the outer side. Such type of curved mirrors are known as convex mirror. Application of convex mirror. Convex mirrors are used as a rear view mirror or side mirror in scooter and cars. They are used as vigilance mirror in big shops and departmental stores. They are also used as vigilance mirror in big shop and departmental stores. Now we discuss about terms related to curved mirror. The midpoint of curved mirror is called the pole. Look at the figure. Here P is the pole of the mirror. It is a concave mirror. Its outer surface is polished and the reflection takes place from the inner side. And the midpoint of the curved mirror, P is the midpoint of this curved mirror. So P is called the pole of the mirror. It is denoted by P. You see here. Consider that the curved mirror is the part of a sphere. We know that any kind of spherical mirror is a part of a sphere. The midpoint of the sphere of which the mirror is a part is called the center of curvature. and center of curvature is denoted by C. C is the center of the sphere from which or of which the mirror is a part. Therefore, C is called the center of curvature of the spherical mirror. The radius of sphere of which the mirror is a part is called the radius of curvature. Here Cp, the length of Cp is the radius of curvature, which is the radius of the sphere of which the spherical mirror is a part. And the radius of curvature is denoted by capital R. The line joining the pole and center of curvature is called the principal axis. The line joining the pole, P is the pole, and center of curvature, C, is called the principal axis. The point on the principal axis of the mirror at which the light rays coming parallel to the axis actually meet after reflection or appear to meet is called the focus of the mirror. You see in this figure some light rays parallel to the principal axis coming parallel to the principal axis after reflection meet at a point, and that point is called the focus of the mirror, and it is denoted by F. The distance between pole and focus is the focal length of the mirror. The distance between P and F, P is the pole and F is the focus. The distance between pole and focus is called the focal length of the mirror. The focal point is the point on the principal axis at which the rays of light coming parallel to the principal axis meet after reflection in case of concave mirror and appears to meet in case of convex mirror. They actually meet in case of concave mirror but appears to meet in case of convex mirror. Now we discuss about, you see here it is the convex mirror, its outer surface, its inner surface is polished and the reflection takes place from outer surface. The light rays coming parallel to the principal axis after reflection, they appear to meet at a point on the principal axis. That point is called focus of the convex mirror. Now we are going to discuss about real and virtual images. The images formed by a mirror may be real or virtual. The image which can be kept on a screen are called real image. The images which cannot be obtained or kept on a screen are called virtual image. The image which can be formed on a screen are called real image, and the image which cannot be formed on a screen are called virtual image. Now distinguish between real image and virtual image. Real image is the image which can be projected on a screen, which can be obtained on a screen, but virtual image is an image which cannot be projected on a screen, which cannot be kept on a screen, which cannot be held on a screen. In case of real image, the rays of light actually meet at a point after reflection, but in case of virtual image, the rays of light appear to meet at a point after reflection. The image form is inverted. In case of a real image, the real image is inverted, but virtual image is erect. Real image is formed in front of the mirror. Virtual image is formed behind the mirror. These are the basic differences between real and virtual image. Now, image formation by curved mirrors. A mirror forms the image of the object kept in front of it. When an object is kept in front of a mirror, then its image formed the image formed in the mirror. The image formed is not always the same and varies with the distance of the object from the mirror. We can understand this variation in the position, size and nature of the image formed with the help of the geometrical construction known as ray diagram. With the help of the ray diagram, we can understand the variation in position, size, nature of the image formed by the spherical mirror. So to draw the ray diagrams, we have to follow some basic rules. So now let us discuss about the rules for drawing ray diagrams. Rule 1. If the incident ray is parallel to the principal axis, then the reflected ray passes through the principal focus in case of a concave mirror, or appear to pass through the principal focus in case of a convex mirror. It is very important to remember the rules for drawing ray diagrams. If you don't remember and understand properly the rules for drawing ray diagrams, then you cannot be able to draw the images formed by the mirror. So be careful about it. It is a concave mirror and this is a ray coming parallel to the principal axis, and after striking in the reflecting surface of the mirror, it passes through the principal focus F, which is located on the principal axis. But in case of convex mirror, this ray coming parallel to the principal axis, after reflection, it appears to meet at principal focus. If the incident ray passes through the center of curvature or appears to pass through the center of curvature, then the reflected ray retraces the path. That is, the incident ray gets reflected back along the same path. You see, in case of concave mirror, the ray which the incident ray of light or the ray of light which passes through the center of curvature and strikes the reflecting surface, then after reflection it follows the same path, or it passes through the center of curvature in case of concave mirror, but it appears to passes through the center of curvature in case of convex mirror. If the incident ray strikes the pole making an angle with the principal axis, then the reflected ray also makes the same angle with the principal axis. This means that the angle of reflection is equal to the angle of incidence. You see here in concave mirror, if the incident ray makes some angle with the principal axis, then the reflected ray also makes the same angle with the principal axis, which follows the laws of reflection in both concave and convex mirror. If the incident ray passes through the focus or appear to pass through the focus, then the reflected ray becomes parallel to the principal axis. You see here the ray of light which passes through the principal axis, after reflection it goes parallel with the principal axis in case of concave mirror, and in case of convex mirror it goes parallel with the principal axis. Now we are well versed with the rules used to draw the ray diagram. Now let us learn how about image formation by curved mirror. Image formation by concave mirror. When an object is placed at infinity, the image formed by a concave mirror is the object is at infinity, formed at the principal focus, the image formed is real, inverted, and highly diminished or point-sized. Diminished means very small size. Highly diminished means very small in size. That is point-sized. You see, in concave mirror, when the object is at infinity, these rays coming parallel to the principal axis. After reflection, they meet at principal focus. So, the image formed is point-sized. When the object is placed beyond the center of curvature, the image formed by a concave mirror is formed at the point between the center of curvature and focus, real, inverted, and diminished. You see, this is the concave mirror. P is the pole, F is the focus, C is the center of curvature. An object AB is placed in front of the mirror beyond center of curvature. A ray of light parallel to the principal axis when strikes the mirror surface, it passes through the focus. Another ray of light which passes through the principal focus after reflection goes parallel with the principal axis, and these two reflected rays meet at point B dash. Now here A dash, B dash is the image, and the image is formed between the center of curvature C and focus F. Here the object is AB, but the image is A dash B dash. You see, in case of object, the arrowhead is upward, but in case here in image, the arrowhead is downward. It means that the image is inverted, and the size of image is smaller than the size of the object. It means that this image is diminished. The image is formed by the actual meeting of the reflected ray. Therefore, the image formed is real. When the object is placed at the center of curvature, the image formed by a concave mirror is formed at the center of curvature, real, inverted, and same as object. You see, the object is placed at center of curvature. A ray of light parallel to the principal axis strikes the mirror surface, and after reflection it passes through the focus. Another ray of light which passes through the focus, and after reflection it moves parallel with the principal axis. These two reflected rays meet at point B dash. You see, the image is formed at C, means at center of curvature. AB is the object and A dash B dash is the image. Here arrowhead is upward, here arrowhead is downward, so the image is inverted. And the size of the image, the height of AB is equal to the height of A dash B dash. It means that the image is same size as object. When the object is placed between the focal point and the center of curvature, then the image formed by a concave mirror is the image formed beyond the center of curvature. The image is real, inverted, and magnified. You see, here the object is placed between center of curvature and focus. AB is the object. A ray of light parallel to the principal axis strikes the mirror surface, and after reflection it passes through the focus. Another ray of light which passes through the focus hits the reflecting surface of the mirror, and after reflection it moves parallel with the principal axis, and these two reflected rays meet at a point BDS. So at this point, so ADS BDS is the image you see. The image is real. Height of the image is larger than the height of the object. Therefore, the image is magnified. The image is inverted, and the image is formed beyond the sea. These are the features of the mirror. The image formed by the spherical mirror or curved mirror when the object is placed between center of curvature and focus. When the object is placed at the focus, the image formed by a concave mirror is at infinity, real, inverted, and highly magnified. You see, here the object F is the object. The object is placed at F, so F is the object. A ray of light parallel to the principal axis. After reflection passes through the focus, and a ray of light passing through the center of curvature after reflection passes through the center of curvature. Since these two reflected rays are parallel to each other, so they will meet at infinity. It means that the image is formed at infinity. The image is real and inverted since it forms below the principal axis. So it is inverted and it is highly magnified as the parallel rays meet at infinity, so the image is highly magnified. When the object is placed between focus F and pole P, so AB is the image, a ray of light which passes through the center of curvature after reflection passes through the same path. When these two rays are extended behind the mirror, they appear to meet at point BDS. So ADS BDS is the image, and